My name is Naseer. I'm CTO and founder of PingHome, where we help companies to monitor their infrastructure, APIs, servers, and so on. So I have 11 years of experience in software engineering, and I'm AWS certified solution architect. So agenda for this session will be, I'm going to talk about first the myths about serverless, and then we will discover AWS serverless services. Then we will talk about benefits and drawbacks of serverless, and then architecture challenge with real examples that we faced and the challenges, then how we solved it and why we decided to use serverful or server-based services at some points. And then I will be happy to answer your questions. And while I'm talking, if you have any questions and something is not clear, please raise your hand and ask your question. Feel free. So let's start. So one of the myths is the serverless has a cold start problem, so we can't afford slow performance in our system. So the cold start, what's cold start? The cold start when you use serverless services, let's say the AWS Lambda functions or any others like DynamoDB or something, or API gateway, they are not running continuously. So when the service is required, requested or something, the triggered the serverless service, then it needs some time to start to work. It calls cold start. In the beginning, cold start took some time, but now the modern cloud providers improve the service. The cold start is now very fast, so up to 1 second. So right now it's not a big deal, but a very latency intensive applications, it can be some difficulties, but there are a lot of different ways to reduce it, even to avoid cold start. I will talk about some approach later. Another myth is we don't want to be locked into the X cloud provider, and if we use their services, we can never change providers. So basically, as you heard about from the definition, so it's a cloud native approach to build an application. Then there are some dependency on cloud provider, but still, if you build your application in good way, let's say that using hexagonal architecture, when you have adapters and ports, then you can easily shape it's a matter of how effort will you spend for changing it from one cloud provider or even to on-premise or other cloud provider. So the serverless auto-scaling is more expensive and there is no control over the costs. So basically the modern cloud providers provide a lot of configuration and settings to control the scalability. Let's say DynamoDB in AWS. So DynamoDB provides the settings configurations for setting up limitation on write unit and read unit. So you can easily control how much it should be scaled, the up limitation and down limitations. You can control this stuff. So let's look at serverless services from AWS. So the compute in compute categories there are two: AWS Lambda function and Fargate. So Lambda functions basically are event-driven. So if you want to run code to build any API endpoint, you can use a Lambda function easily. And we will talk about Lambda functions a lot. So the AWS Fargate, another version of the compute service from the serverless services, and it's basically mostly used with the Dockerized services. You can run your containers, and you don't manage it yourself. Another category of AWS serverless services is storage. So you are probably most of yours worked already Amazon S3 buckets. It's for file storage and also Elastic File Service, which helps you to share file storage between the servers, and all of them are very doing very high performance, and for scalability, it works really good. DynamoDB is NoSQL version of the storage service, serverless service. So RDS proxy also very interesting service when you want to use connect to RDS itself, which is a relational database service. When you use Lambda function as a compute part or API, and you need to connect to RDS, because the Lambda functions can be running a lot in parallel and concurrency, it can create a lot of connection to RDS, which can lead to the connection limit or so on. So that's why RDS proxy is really good service to have one single point for connection to RDS. Then all your services connect to this service, and then from the RDS, a proxy service to RDS. So also they provide a bunch of other storage services like Aurora for MySQL and Postgres, Redshift for the warehouses, Neptune for Graph, OpenSearch like the fork of Elasticsearch, and Elasticcache with the engines Redis and Memcache. So also AWS serverless services have some services for integration, including EventBridge, step functions. EventBridge is mostly for the event-based architecture. You can use rules, you can schedule, you can do communication, and also step functions are good for workflows. You can build with step functions, ETL pattern like extract, transform, and load to take some data from one service and then make it as an input to another service and make your flows, and all of them are serverless. API gateway, very common use in REST APIs. You can put API gateway in front of Lambda functions and to control the API. And also you can use different HTTP methods, get, post, and delete, and so on. So, and then you can also mock some responses. For example, options, the HTTP method options can be used like the fully mocked. You don't need to pass it to some compute service. So a lot of different options with API gateway that helps developers to build API gateways really efficiently. AppSync is mostly for using GraphQL. The data source can be DynamoDB or some other S3 bucket, and it really helps you efficiently and fast to build a GraphQL implementation. And from here, one of my favorite ones are SQS and SNS, which is SNS is simple queue service, helps developers to implement queue logic very quickly. And it has two options, standard and first in, first out option. And SNS is a simple notification service where services can push notifications. It can be push notification, it can be SMS, it can be even the publishing message which will be consumed by other queues. I will talk about implementation of these two methods also in the architecture examples. So let's talk about benefits of serverless. Effortless efficiency. As I said, so the teams can deploy the services very efficiently and quick without having to think about how to run it. So it's basically very simple and straightforward. And scaling is also very good point here. Let's say DynamoDB Lambda functions, they are scaling really good, and you don't need to think about setting the auto-scaling policies like you do with the normal servers or EC2 instances. So you can it can be scaled itself. So cost-effective. So a lot of companies use these benefits. So when you have microservice architecture or some similar approach, some services, microservices, you don't need to run continuously, and in that point, so you can use Lambda functions or other serverless solutions to not to run every time and continuously, but when it's required, then you are charged as you go. So deployment process is really fast. From my experience, we had in our product, not in current product, but in one of the previous products, we had two different type of services, and we used the microservice architecture. We had normal EC2 instances, and we had Lambda functions. And deployment of EC2 instances took for us every time around 40 minutes to deploy. Of course, it depends on the building image, what you use there. But our modern microservices, which we used Lambda functions, it took around 3 minutes. It's really fast when you use serverless architecture, one of the good benefits. Managing servers and upgrades. So who manage the servers, they know there are from time to time dependencies are going to be should be updated because of the old versions, because of security stuff. So in serverless architecture, you don't need to do it. Mostly Lambda functions or others, they are already managed by cloud providers, and they do updates and what requires. Okay, then what are disadvantages of serverless? Sometimes it can be difficult to test and debug. Limited control also can be one of the disadvantages when you want to really go inside with SSH and check what's happening in the OS level, or what the process are there. So, but now there are also tools to use some local setup of serverless and try it before deployment. Execution time. This one is mostly specific in most of the time the Lambda functions, because Lambda functions have a limitation of 15 minutes to run execution time. So you have to think about how to make it really not to use the long-running processes with the Lambda functions. And some other limitations, including some protocols, I will also share later. Okay, let's move to the architecture patterns. So who is familiar with the pattern saga? Maybe you heard or used. Yeah, the pattern saga is when you use really event-driven architecture. It's basically for implementation of microservices. When one microservice publish the message or event, and then another service listen this event, consume this event, and then does some operations. Let's say in examples, the order is ordered with the post HTTP request, where you see from the point 1, and then order service publish the message that order created, and then customer service consumes or listens to this message, order created. When it happens, then it does specific operations like checking the credit limit or something else. If it's exceeded, then publish another message that credit limit is exceeded. It's asynchronous communication and the pattern where the mostly implemented very efficiently. So why I'm talking about this pattern, just to show you how it can be implemented using AWS serverless solutions. So we talked about SQS and SNS. So here's the simple example how the event-driven architecture can be implemented. As you see, there is a Lambda function as a microservice. They have their queue, SQS. Then if one of the microservices want to publish some event, you can use SNS to publish a message. Then SNS has the topics which we can call, for example, order created can be one topic. Another, like the order failed, can be another topic. These topics, SQS service can subscribe to these topics. When the event is published, then SQS, the message goes to a queue, and this microservice consumes the message from queue and does the operations based on the event type. That's basically how it can be implemented. And if you can see here, the Amazon SQS DLQ. So DLQ is dead letter queue. It helps you to retry. Basically, if messages failed because of some other issues not the fundamental issues. Your microservice can retry the handling of the message. If it fails 5 times or more, you can set up in the config files configuration. If it fails more than specific threshold, the message will go to dead letter queue, where you can debug and see what kind of message are failed and why. You can check it why it failed. So I want to talk about Lambda function as a full service. So I see a lot of companies use Lambda functions as a very tiny for very tiny functionalities. Like, let's say we have a product service, we have customer service, and you want to implement different endpoints, get, post, delete. And some companies use multiple Lambda functions to handle it. For example, for post request, another Lambda function; for get, for another Lambda function. Basically, multiple functions for the same domain. But in reality, Lambda functions can more. You can use Lambda function, the single Lambda function, for as a full service. Even there is a framework from the AWS team based on Python, AWS Chalice, as you see from the screenshot. It can be used a fully web service. It already includes REST API endpoints or handlers controller structure for the handling for using Lambda function as a full service. Also, the same microservice can be triggered based on SQS event, based on API gateway event, which means HTTP requests based on the different the HTTP methods. Also, it can be triggered when something happened in S3 bucket, like some events, the same the microservice. What's the benefit of using the same microservice? When you have the domain logic in the microservice, you can reuse the same code for same entities, same properties or whatever in the same code. You don't need to copy paste or duplicate the code in multiple Lambda functions, which is not needed. So you can use the same Lambda function for same domain in microservice architecture. So another thing I would like to talk about in microservice architecture also can be cases when you need to do synchronous communication. The first, with the event-driven architecture, it's about asynchronous, but here also you can need some time to do inter-service communication. You can achieve it using API gateway in front of Lambda function, which I also see in companies teams are doing. But what we implemented in our company, we looked at, and we don't need API gateway. We use a Lambda function invocation functionality, just directly to call from the one Lambda function to another, invoke another Lambda function, and we set the protocol between the services that, for example, the if payload has this subject, some subject, then it understands that the one service requires a specific data. Also, there is a routing, and we handle these requests and return this the requested information. Another solution that I want to share with you, as we said, there is a limitation in execution time of the Lambda functions. You can implement SQS, and with SQS you can achieve this. We call it a sequential recursive invocation approach. When every time you use, for example, you want to scan the big data from the DynamoDB, and you don't want to do it with the one go, and we want to do it with iterations, then you can use the last evaluated key from the DynamoDB records when you scan it, then do the loop, and then you can execute Lambda, extend the execution time of Lambda functions, and you can achieve it. We use this approach for the generating reports and so on. So basically, we don't need to use the long execution time and so on. So I want to talk about also challenge what we face it. this is an example of our checker service. So as I mentioned, we are doing monitoring solutions. So one of the module is uptime monitoring. So we have one microservice we call checker service. So we initially used the Lambda function for that when we had our MVP, where we just needed some HTTP request, TCP or UDP, using TCP or UDP protocols, or just HTTP protocol. Basically, how it worked. So this Lambda function getting the targets from the messaging queue, the same architecture that I talked about. Then we checked all the targets using these protocols. Then we collect the responses, response times, and so on. Then we publish the message. Then another microservice take care about the data, storing it, and then showing statistic and the charts to the front-end applications. That's the architecture that we had initially using Lambda functions. Then we got some feedback from customers that the response times are not stable somehow, but in reality they should be stable. Then we took this feedback and started investigation, and we saw that really there are some batches during the checking the targets. We got response spikes. Which is not like normally the endpoint response like within the 100 milliseconds, but without some reason at some point it was higher. Then we saw that it happens to specific batches from time to time to all targets. Then at the meantime we also wanted we started to look at solutions, how we can solve it. If you remember from the limitations and also the myths that people say the cold starts can lead to low performance. Whereas one of the ways to avoid cold start in AWS, you can use the provisioned concurrencies. So we also looked at this solution. Maybe this issue comes from the cold start problem. We use this option that we introduced the provision concurrency to reserve some Lambda functions and running them, keeping them warmed up, but still we couldn't solve it with this. Then another solution we wanted to try to publish message every time in advance, just dummy message to warm up the checker service and to solve the problem if it was related also again that cold starts. Then in the meantime we needed another feature to build another feature, which was the ping monitoring. So in uptime monitoring we had like the normal HTTP request checking, like we had using TCP protocol, UDP protocol, but we didn't have the ping monitoring, which is another protocol, ICMP protocol. Then we wanted to implement this protocol also using same checker service because we check everything from there. Then we faced with Lambda limitations. So only TCP and UDP sockets are supported. Then we couldn't use ICMP protocol with the Lambda function. It was one of the limitations also. Then we decided to move to ECS. Because of these not stable response times and protocol limitation. But also we kept ECS Fargate with we used ECS Fargate service, which is also serverless, but different from the Lambda function. Also, it costs a little bit more than Lambda function. After that, we transforming it to ECS version, so it became a stable response time. Then we also could implement ICMP protocol. And one point here, so if you remember, we talked about we don't want to be locked into X cloud provider. So during doing this migration from Lambda to ECS service, we realized that it can be easily migrated to another form of servers. It can be Dockerized if you implemented your microservices properly. As I said, so if you, for example, use ports and adapters pattern, like which is hexagonal pattern, you have adapters. You can put another adapter to the port, like logically, and use it. So this kind of implementations makes your project very flexible if you want to change some services. So other challenge we had, we wanted to build the new model, which is status page. Probably all developers are familiar with status page. For example, GitHub status page. When something doesn't work, then you go to this product status page and you check what services are down, what are operational. So basically, part of our product, we wanted to implement new model, which is status page, and this model requires to give possibility to create custom domains like status.example.com. Any company could go to the platform and create their own status page. What challenge we had? So custom domain and SSL certificates, how to manage them using serverless, because our mission from the beginning was to use only serverless and use serverless as much as much as possible. And let's look at traditional ways how it is done. When you want to create custom domains and SSL manage SSL certificates for the custom domains, basically a lot of companies use like traditional ways with Nginx, and then Nginx manage the SSL termination, then request goes to another service. That's the example configuration. So the path to SSL certificates, and you show the server name, which is domain with subdomain. And for example, that's how implemented one of our competitors using Nginx and Caddy. Caddy is managing SSL certificates and renewing it, and also it used as a provider Let's Encrypt. As you see from the response headers for testing, I created a custom subdomain with our development domain, and the server they use is Caddy and Nginx. So nothing wrong with this approach. It also can be used, but as I said, our mission was to use serverless as much as possible. We started to look at solutions how we can achieve custom domains and managing SSL certificates for the custom domains. Just as information, when you create your own domains or own custom domains, it's very easy to manage in AWS. You just create new subdomain. If you use, depending on which service you use, like the API gateway, you always have a chance to create custom domains for your own domain and create SSL certificate. It will be managed by AWS itself. But in this case, it's different. So the customers should be able to create their custom domain. So how we use it, we give them the CNAME, which they put to DNS records. So they create their custom domain, and as a value of the record, they put our CNAME. What was the issue? It's one of the examples how it can be done. One custom domain is created, and with the route 53, it's directed to EEL application load balancer, and Nginx can manage this custom domain and SSL certificate stuff. So we started to think about how we can implement. The first attempt was to create the proxy service, our own proxy service using Lambda functions. As I mentioned, we wanted to make it serverless. So, and API gateway, we put API gateway in front of Lambda function. Then we faced that everything worked without HTTP. We could achieve the without HTTPS. Everything worked with HTTP. So we have S3 static website. We used static site generation for the UI, and then in the end we had status page service, which is backend service, and the users could see their data about status of services they created. And we take normally the host name which requested, then based on the host name, for example, status.example.com, based on that we generate the page. So for that, for this operation, we needed proxy service. We created it, and then for SSL certificates, we got problems, limitations of the these serverless solutions. So we had a problem with API gateway. There's no option to use SSL certificate for domain out of your with domains that you are not added to your Route 53. So we couldn't have it, and also custom domain count limitations were there in API gateway. Then we tried application load balancer. Application load balancer has option to add custom generated SSL certificate, and you could just add it to application load balancer. So, but there we had limitation with the count. Each application load balancer has limitation up to 25 SSL certificates. So basically, when we have like customers created a different status page, like hundreds of status pages. So for each 25 custom domain, we should generate SSL certificate and add to application load balancer, which wasn't option for us. Then we thought about network load balancer. Network load balancer cannot trigger the Lambda function. Also, was one of the issues. As I mentioned, so multiple load balancer wasn't the case because it's not cost effective. Each load balancer costs money, and we could achieve the result, but it is not a good solution. Then we tried network load balancer, but we changed Lambda function to ECS proxy service because, as I said, network load balancer couldn't trigger Lambda function directly. Then we started implementing this solution, network load balancer. Not sure if you're familiar. The network load balancer and application load balancers have differences in the layer OCI level. So application load balancer works with the layer 7, which is the application layer. They mostly works with HTTP, HTTPS, but network load balancer is the lower level. It's the level 4, which works mostly with TCP and UDP as a raw connection. So this solution started to work. So we could implement custom domains, custom subdomains with the ECS proxy service. So it's the simplified version of the architecture where we had SSL manager service, where we check, we store the information in DynamoDB about the customer's subdomains, custom domains. Once they are connected, their CNAME record with our the DNS, we could renew a SSL certificate using the Let's Encrypt, and every time check the expiration date, then put it to S3 bucket that you see from the top. Then our ECS proxy service, using these SSL certificates and storing it in Elastic File Service, which is shared storage service and very high performance. Then how it worked from the flow, the user makes request to the domain name, as you see in examples, and it goes to our CNAME record, which is in the Route 53, and then it redirects the request to our network load balancer, and then network load balancer triggers ECS proxy services. So ECS proxy services can be scaled. You can based on load, you can multiply the containers and scale it out. So we implemented our own small lightweight ECS proxy service using Golang, and then this architecture worked pretty well. So it's still the kind of serverless. Only network load balancer is not from the serverless services, but still it's we don't manage it. We just use it. So it's also kind of serverless friendly, let's say. That was the result from our proxy service. Basically, we could achieve really good performance. So normally in server header, you can see the Nginx or something, but we created our own ping-pong proxy. we could do a lot of customization in the proxy request when we need it. So performance also good under the 50 milliseconds. So basically, yeah, I shared my experience with you, how we implemented serverless solutions, how you can use it, what challenge we had. I'm happy to listen to your questions and answer.